what's called an instrumented version of it, where you can measure the code coverage that's being achieved. And you look at the purely requirements-based set of tests, it's not unusual to see that you're actually only covering about 20% of the code, which is a pretty dismal observation, I suppose you could say. But it is the case that that is often a lot of holes in your code coverage when you use purely requirements-based type of approach. So it would be good to know what 80% of the code you're not testing, so that you can figure out, is this something I need to worry about? Is this a hole that I need to fill? And that's an important aspect, even if you're not involved in doing unit testing. If you're just a system tester or acceptance tester, and you say, hey, why do I need to know this? How does this help me? Well, it helps you know what you're not testing with your black box tests, so that you can think about what you might want to add to cover that. So basically, what we're doing when we're doing a code coverage analysis or a form of white box testing, we are designing tests based on how the system works internally. And again, this can be either via the control flows, looking at how control flows through the system, and again, control flows just refers to the sequencing of statements. We can look at data flows, which is figuring out, as I said, how the data moves through data structures. And we can also use standard checklists or bug taxonomies to guide our testing. Say, well, we're going to look for a particular kind of bug, and that's the Merrick technique that we'll look at. Now, it is possible to do code coverage analysis manually, but possible only in the literal meaning of the word possible, like there is a path to get there. Just as it is possible to traverse the entire world with a pair of boots and a kayak. If you could conceivably do that, but you might not enjoy the experience, and you might not even survive it, because it would involve walking through the code as you ran your tests and looking at what was covered and what was not. And that's going to be a very, very painful experience, very tedious, and very easy to make mistakes. So typically you are going to want to use some sort of code coverage analysis tool, such as the ones that I mentioned earlier, that will instrument the code and then produce a report for you at the end of that process. And you can find both open source and commercial code coverage tools. I've seen and used both. So, excuse me. Let's look at a couple more details here. I get some water for my poor throat. So let's start with code-based control flow types of tests. And again, control flow refers to the sequencing of statements and looking at different sequences of statements that can occur. Now, the big kahuna of control flow coverage, if you will, is what's called path coverage, which would be that if you were to take the statements and number them, and if you achieved path coverage, then every possible numerical sequence of statements that could occur would have been tested at least once. Now, as a practical matter, that is impossible, because generally speaking, you have an infinite number of potential paths through the code in any sort of real-world scale system. You've got a lot of loops, and you've got a lot of branches and so forth, and some of those loops have an indeterminate number of things that they can process, and in some cases the application can run indefinitely. So there really is no way to achieve path coverage. So we're going to have to scale down from that. We're going to have to say, well, what are there in the way of achievable levels of code coverage? So one of the levels of code coverage, the lowest level of code coverage, is statement coverage. Now, in statement coverage, what we're saying is we want to make sure that every executable statement in the program has been executed at least once. Now, notice I said executable statements, so I'm excluding comments and compiler directives and those sort of things. Most programming languages have non-executable statements that can occur, but every programming language that I've ever used, and I've used quite a few of them in my career, has some fundamental concept of the executable statement, which is some atomic unit of processing where you assign a value to a variable, or you perform a calculation on a variable, or you do nothing. In some cases that can be a statement, just a semicolon by itself on a line. So however the concept of a statement is defined for a language, you've achieved statement coverage when every statement, which is defined as an executable statement by the programming language, has been executed at least once by some test. And again, the practical way of doing this, you're going to have a program that's going to produce what's called an instrumented version of the code. And that will have probes inserted into the code that will keep track of where the control flows. And it'll be able to know whether you've gotten to a particular block of statements. And if you've entered a block of statements that consists simply of executable statements, non-branching, non-looping type of statements, then you will run that entire collection of statements from beginning to end. So if you run the first one, you'll run the last one in that sequence. So if you think of a block in for example, C, starts with a curly brace, and then there's a sequence of statements in it. And assuming that it doesn't contain any ifs or fors or switch cases or anything like that, then the last curly brace terminates the block. If you run the first statement in that block, you will run every statement in that block. So statement coverage is going to keep track of that, and if you're using a tool, you'll be looking at have these statements been covered. And many times the tools will be nice, and they'll after you've run the program, you can actually step through the code, and it will color indicate in some way in the code whether something has or hasn't been touched by the tests. So you'll be able to see that. Now in branch coverage, we're going to say, well, all right, it's good to get statement coverage, but software exists to make decisions, basically to do one thing or another. I mean, if everything could be done through a single sequence of executable statements, and anything could theoretically be done with a calculator, but in branch coverage, we're saying, well, a control is going to flow, and it's going to get to a point where there's something like an if statement or a switch case construct or something like that. And we want to make sure that every branch, every decision that can be taken has been taken each way. So for an if statement, then we have a true side and we have a false side of the if. For a switch case construct, we have the case blocks, which are the labeled blocks that the switch directs the control flow to based on the value of the switch variable. And we also have the default block. And you should remember that in an if statement, even if there is no defined else, there is always an else in the sense that there's an else branch. There's an else do nothing that always is a possibility in the code. And the same is true with the switch case. I mean, even if you do not defined a specific default block, then there's still going to be